tackle the problem y double prime plus y equals tangent of x. And we know that our complementary solution is going to be c1 cosine of x plus c2 sine of x. So that means that our y1 is going to be cosine of x, and our y2 is going to be sine of x. This formula is actually symmetric with respect to y1 and y2, so if you mix them up, it doesn't matter. Our capital F is tangent of x, of course, and then our Wronskian is going to be the determinant of the 2 by 2 matrix where we have cosine x, and then the derivative of cosine x, which is minus sine x, and then the other function y2, and then the derivative of y2. So this is going to end up being cosine squared of x plus sine squared of x, which in this case happens to be a constant. In general, it'll be a function of x. But in this case, it's a constant, which is just 1. Okay, so our Wronskian of x is just 1. And with that, we can find the particular solution. The particular solution is going to be minus y1, so minus cosine of x, times the integral of, let's see, sine of x times tangent of x. We would also normally divide by the Wronskian, but the Wronskian is just 1. Okay, and then plus, let's see, y2 is sine of x times the integral of cosine of x tangent of x dx. And now our job relies on finding these integrals. Find the integral of sine of x tangent of x, and find the integral of cosine of x tangent of x. This integral, the right integral, is the easier one because tangent is sine over cosine. The cosines cancel. You end up with let's see, the integral of sine, which would be negative cosine. So this will be sine of x times negative cosine. And then from here, we need to figure out what is what's going to be the integral of sine times tangent of x. So we'll have to come back and we'll fill that in just a second. So let's work on that. So that's going to be sine of x times tangent of x. This is, if we don't know what else to do, always write it in terms of sine and cosine. This is sine squared over cosine, which is 1 minus cosine squared over cosine, which is, let's see, the integral of secant of x minus cosine of x dx. And the integral of secant, I'm sure you all know well, is the natural log of secant of x plus tangent of x. Okay, and then the integral of cosine of x is going to be sine of x. So it turns out that this is the quantity that's going to go here. And it turns out that our particular solution, so y sub p, is going to be negative cosine of x times the natural log of secant of x plus tangent of x. I should probably have absolute values here, but that's okay. Minus sine of x plus sine of x times negative cosine of x. And so if we were to distribute the negative cosine of x through, what would happen is we would get plus cosine sine minus cosine times sine. And then what that leaves us with is, I shouldn't have crossed off this term. This leaves us with our particular solution is being, so our particular solution is going to be negative cosine of x times the natural log of secant of x plus tangent of x. And again, we can just assume everything's positive and ignore, we can ignore the absolute value signs there. That's our particular solution, and finally, one small step past that is the general solution. We're going to get c1 cosine of x plus c2 sine of x plus the particular solution, which is minus cosine of x natural log secant of x plus tangent of x. And there we are. Okay, so definitely a lot more complicated, a lot more involved than what we were doing previously. So that tangent of x, even though it involves sine and cosine, is still it's still significantly harder than what we were doing before.